Are you expecting to see images like these in the telescopes tonight?
I'm not sure.
Okay, well, for the most part, no. Your eyes work very differently from a camera that would produce photos like these. Mainly, it's because our eyes can't take a time exposure like a camera can. Our eyes act like snapshots. The light comes into our eye, the signal passes on to our brain, and is gone. Will staring at my face make it any brighter?
No.
No, okay. Well, here's a galaxy far out in space. Hold it over the telescope opening here. A little lower, there you go. And we'll use these grains to represent photons, or packets of light, coming from this galaxy and hitting this area in 1 second. Okay? 1001. Okay, let's see. Now that's all the light that our eye will pick up from the telescope. You'll see a little fuzzy patch of light when you look through the scope. Now let's pretend that there's a CCD camera, like a digital camera, connected to the telescope that can collect photons over a longer period of time. Okay? So now let's take a time exposure and sprinkle these photons into the telescope for about 5 seconds. Here, you want to do that? Yeah. 1001, 1002, 1003, 1004, 1005. Okay. Now let's see.
Oh, cool. How do you do that?
Ooh, okay. Well, now a camera can collect and produce a much brighter image than you'll see with your eye. Professional telescopes like NASA uses don't use eyepieces. Even if you could go up in space to the Hubble Space Telescope, you wouldn't be able to look through it. Those telescopes use various kinds of detectors and light collecting devices like CCD cameras to allow us to understand the universe by analyzing the light they collect. But when you look through the telescopes tonight, you'll be experiencing the real universe, not photographs.
So what are we going to see tonight?
Another reason you won't see images like these in the telescope is that some of these use representational color, using color to represent light that would otherwise be invisible to our eyes, like X-ray and infrared. This card sorting game introduces that concept. You might want to use Rusty and the USA cards to introduce the game. Scientists learn a lot from the light we see coming to us from the rest of the universe. But there is more to light than just visible light. There is more energetic light, ultraviolet, X-ray, gamma ray, and less energetic light, infrared and radio, that our eyes cannot detect. We need other kinds of detectors and a different way to picture what is emitting that light. To get a complete picture and understanding of something, we need to look at it in a variety of ways. This is Rusty. Can you tell by looking at Rusty which parts are warm, which cold?
No.
Does Rusty ever actually look like this?
I hope not.
This is an infrared photo that shows us the temperature of Rusty. Which parts of Rusty are the warmest?
His eyes and mouth.
Which coolest?
His fur and definitely his nose.
What color is being used to represent the warmest parts?
Yellow and white.
Could we have used other colors to represent the different temperatures?
Sure.
Right. Any color at all. We're using representational color. We are taking energy we can't see and converting it into something our eyes can interpret. Different colors representing different temperatures. The same is true for some of the great astronomy pictures you see. The colors are beautiful, but more often they are representational color, telling a much richer story to the astronomer who created it. The colors may represent what the object is made of, or signal strength. I think we're ready to play the universe in a different light. Each card tells you on the back whether it is visible light energy or another kind of light energy, and what that energy is revealing about the object. The visible light image tells you what the object is. You need to match those up with the object as it would appear in other light energies. There are 9 objects represented and 3 different images for each object. Which ones go together? Sort them into groups that represent the same object. When playing the game, if you have a large group of people, you might want to give each person an image. Let them try to find their matching buddies and group themselves. If you have a young or beginner's group, you may want to use only 5 or 6 objects instead of all 9. You'll note that some of the playing cards have a slight gray border. These are suggested beginners groups of playing cards. Here are the answers. How well did we do? What do these images tell us about the objects that our eyes alone can't detect?